Tabs on that tin something. Yeah, Molly.
There's so many guys.
Shane's gonna be.
Yeah, if anyone needs a teacher for their team, we could change the name too. If y'all need a teacher, we're going. We're going. We're getting after it.
We kicked the press out. You just move straight down with the ball.
All right. Hey, did y'all do these yet? Numbers 1 through 4? If you've done them, I've got tickets for you. Okay, I've got tickets for them. So this is where we say, where on my unit circle is cotangent of x going to be negative square root of 3 over 3? So tell me the angle. That's kind of what we're doing there. We're solving for what angle, really angles that we could find, right? I'm going to see, let me see if I can pull up the unit circle. Oh, you got, that way we have it. What's up, dude?
What was on?
Say again?
Yuck.
Were you like no shots?
This should be square root of 3 over 2.
I saw one.
Got it. Just flip flop it. If you need to, take out that unit circle if you've got one, and that should be able to kind of help you out there. Here's one, that way you've got it right here. The first group that can get those right, I've got tickets for.
What? Coach said, I didn't get a homework.
I can get you one, did I? I've got one back. Did I get y'all one too?
Okay, I am doing that right now. Okay, look. Okay.
Not as we do.
What is that?
Remember, number one score all from Georgia. Dude, it's funny classifications. 59, not 52.
Good shit. I think I got it.
Good, Caleb. Good job. I saw that.
You call us shit.
Oh, is that all?
It's funny.
I think there's 2 locations for a lot of these. You know what I'm saying? So this one actually, because this is where sine is -1, right? Because it's -1 over 1, flip it. So there's only one location here, right? But for the other ones, I think there's multiple locations. That's what we're trying to find. Did y'all get these yet? These down here, Graham? Do y'all remember this?
Oh, is this gonna be on this unit again?
There's a little difference. I just need you to pull this back up, your knowledge of it, because it will help with where we're headed. Does that make sense? So no, but yes. So not the same, a little different, but the same idea. If you understand this, it's going to really help you. Really help.
Is the first one 150?
Yes, that's one of them. That's one of them.
Is there another one?
Actually, it's cotangent, right? So it's not 150. It's actually because.
Is it 1 over X over Y?
Oh yeah.
Yes. It's not 150 because this is 150, right? This would be y over x. If I did that, that would be
Oh, so
tangent.
120.
That'd be it. Yeah, but that's one of them, right? It's one of them there.
Yeah.
It worked. Hey, if you've got any extras, let me know. Ty, did you help out?
Yeah.
I really don't want to
Are we
risk
all?
I really would.
I taught myself how to write it. I taught myself how to write
This is going to be homework once we go through it.
it.
It's a little different, but similar to what we just did. All right, Kayla's got it. Let's see if Kayla and her team's in.
I think it's super cool.
I'm gonna have to bring it to school. Bring it to school and write it.
Oh,
I
brought my skateboard.
Okay, this you switch. Nice. Good. Are y'all all together? Team is together. I love it.
Do we have to show work?
You do not on these. No, you don't really have to.
No, post against 1 over 9. So
Then I'll give you a
sign
filled out
going to be
one.
negative. It'll have
What quadrant?
something negative.
I'll roll, and
So
then
that's where I'm negative 1.
just one quadrant. It's not the majority of it, but it is a quadrant.
The basement floor is the best.
Oh, I see. Okay, I see. So, yeah, two all.
Oh. Savannah, did y'all get it too?
What?
I'll give you like 20, 30 seconds to wrap it up there.
We're 1 negative.
You lost the question.
Do they say?
Remember the kid who said, I don't care how many stars you have.
Yeah, I know what you're talking. I know which ones are which.
Awesome and
3, 5, 4, and 5, 5, 4. Done. Good job, team.
Yeah, I think so.
Hey, did anybody struggle on these?
So they're good.
Yeah, a little bit. Okay. All right, so let's do this. We're gonna go through this today. I think it was I forgot who. I thought it was maybe either Graham or Thomas that just asked, "Hey, are we gonna have to know this again?" Or maybe it was Diego. Would you have to know this again? Well, I will tell you this: if we can actually remember this stuff, the rest of where we're headed is gonna make it much easier. There is a little bit of a tweak there, but if we can get this, it's gonna make what we're gonna do much, much easier. Okay? Let me give you the schedule for today, and then we're going to hop into the lesson at the beginning. At the end of today, we're going to do a review game that I think I've done one time, and I actually like it. I'm curious to see if you do too. I think it'll be a lot of fun. So we'll pull from what we did today as a little review game. Obviously, we have our block party. Thank you for everybody who brought the stuff. How I like to do this is I get the lesson done at the beginning when everyone's eating, because when that happens, it makes the lesson or lecture part much better when we have food and stuff like that, okay? So we'll do that at the beginning. At the middle spot, I've got a character development that I'm pumped about. It's pretty exciting. I think it's something that means a lot to me. So I'm going to share that, and I hope that it means a lot to you as well. And so that's kind of the game plan, kind of bookend it there. The homework, 4.7, there is no A and B. I hope, look at the homework real quick. Do you like the spacing better?
Yes.
I tried to help you out with that much better. Sometimes I'll probably do a good job, sometimes I may not. But I try to guess how much space it will take. But there is no A and B. There is just 4.7. That 4.7 will be due on Saturday. Okay. As you look out in the future, the test that you will take will be on the block day before homecoming next week. Okay. I don't think you want that test to be on Friday. I just don't think so. So I want to get it done before we go into homecoming on Friday and then homecoming weekend, which is just a lot of stuff going on, okay? So just as you think about that, that's where we're headed. We'll have a review day next week, and we'll go from there, all right?
Is homecoming Friday or Saturday?
Homecoming dance is on Saturday, but homecoming like football game with like everyone on the court is on Friday. Okay? Questions? Cool. Hey, let me pray for us. Any prayer requests before we pray and kind of get going?
Schools.
Sorry.
And then you need some more motivation.
Fair. I think all of us did, right? All of us did. It's good. Savannah.
My dad's defending his dissertation tonight, so
This is a big deal. Are you going to be there?
I don't know, but we're like planning a little like celebration for him.
So exciting.
I want to kill you.
That's standard space grading.
I'll be honest, if you have not ever looked at what a dissertation entails, just one time, don't have to read one, just look through it. And I did a mini dissertation, and I was like, it is very intense. Savannah would tell you because she's seen it firsthand. So we will pray for him, and we will pray for celebration afterwards, for sure. That's great. Anybody else prayer requests? Anything going on? School stress. Yeah, I agree on that. Let me pray for us, pray for you, and then we'll get it rolling, okay? God, we know that today there is a ton going on. There's a lot of stuff that we're excited about transitioning to next week with homecoming and things that are coming up. But we know that before then, we have a lot that's kind of in front of us. School, as Thomas brought up, and and as a lot of people confirm, just the stress level of things that are just over top of us, things that we're trying to balance with sports. A lot of us are in some type of sport, and then also school. It seems as though it's impossible to balance everything. But Lord, we ask for strength today. We ask for guidance in that. We ask specifically for Savannah and her family at this time. We're really pumped about Mr. Hill and just his ability to defend that dissertation. Lord, help him with that. God, you be glorified through this class and as we go. Lord, bless this food as we're about ready to eat it. Thank you for the individuals in this class. In your name we pray. Amen. So funny story before we get into the lesson and before we eat. My wife yesterday, I was like, I need plates. Do you have any plates? And she said, no, we don't. I have to go get some. And she's like, why do you need those? And I said, well, we're having a block party. And she was like, why? And I was like, because we can. We can. We can. It's a class. We can go ahead and do it. I want you to know this, and I'm not just throwing smoke up. I want you to know I value you and I love you guys to death. Y'all have rocked it this year. Okay, I want you to know that. I've had a lot of good groups, and I've taught seniors now for 3 or 4 years. And I understand there's going to be challenges as we approach closer and closer to graduation and everything, and I get that. But I want you to hear me that you're valued, and man, y'all are awesome. So keep it up. Today is just a celebration for what y'all have done so far. Whether you realize it or not, if this is graduation from here to here, y'all are like right here. Like think about that. You don't have very long. Like can you hear the music already? Like it's almost here. So continue to stay focused on that. I just want you to know that in the midst of stress and stuff, there's a lot going on. You're valued. Keep it going. Okay? Keep it going. All right? All right, so with that being said, here's how we normally operate with this. I've always done it this way, and I think it just makes it better. I keep that open. That whole table will be open for the entire time that I'm talking, okay? As long as it's not like a distraction, I'm good, okay? Those that brought something today, I always allow to go first. And then those that then you didn't bring something at that point, maybe you wanted to or whatever, but just didn't get to, you all will go after everybody kind of done with that first group. Sound good? And then we just kind of keep it open and then go from there. I know there's plates that Caleb brought with some, I know there's some drinks. Some of that stuff y'all brought, some of the stuff is left over from the last class. So hallelujah for the last class too, okay? But thank you again for bringing stuff. I love this. Love that y'all did that. And we'll just go ahead and keep that there, okay? Awesome. All right, so if you brought stuff, you can go ahead. Let's go. And we're going to get started with what's behind me. While y'all are doing that, are y'all good while you're getting through with me talking? Y'all cool with that? Okay. That way we can continue to go. I am still podcasting. So I've podcasted for now. It's going to be 2 hours. But what I'll do is just so I don't forget, I usually trim them. Yeah, I usually trim them. So, I appreciate it, though, because I need it. Man, I need it.
That's going to be a good little.
Let's see here.
I'll rotate.
See, is anyone out today? I thought I saw everybody. Savannah, Celeste, Ty, Karis. She's not. She's not. She was. She moved to first period, I believe. Elijah, Josh, Kayla, Ken. That's what I thought. We got everybody here. Okay. Hey. Some of you said just a second ago that you struggled with what we were doing with the problems down below. Okay. So what I'd like to do is just quickly talk through a couple of them. I might hand out tickets for those of you who are like, man, yeah, this is how you would do it. And just as a reminder. So real quick, let's talk about cosecant. We'll start from the right, move to the left. As we look at cosecant of -1, a lot of times I don't talk about cosecant. I talk in terms of sine, right? So if I flip the cosecant to sine, that means sine of x equals what?
1.
Good point. It would still be -1. Because even if I flipped it, right, I would still flip it to where it would be a value of -1. So now, if you remember, we go to our unit circle, right? We go backwards, and we say at what angle would sine be -1? And I think there's only one spot in that instance.
Oh, no.
Where would it be, Kenan?
3 pi over 2.
Good. Does that make sense? So you would just put 3 pi over 2 as our answer. Y'all good on that?
Sick.
Awesome. Okay, let's go to the next one. Secant of x equals negative square root of 2. Does someone want to just kind of do the same thing and just help me out with what I would do with that? Josh?
So secant is cosine.
Good.
1 over cosine. So you know where's cosine. It'd be 1 over negative.
Good. Nicely done. And then I don't like that in the bottom, right? So I multiply, rationalize it. That's a good word. So this equals negative square root of 2 over 2. So the question is on the unit circle, where is, and I don't think it's actually up here. And remember, there should be a 45 degree. That's in each of these, here, here, and around. But if I were to do it, where would cosine be negative square root of 2 over 2?
4 pi or 5 pi over 4.
5 pi over 4, Aim? I think it was
3 pi over 4.
3 pi over 4? Nice. Nice. Good, good, good. And that's how I would find those values that are there, okay? Is this ringing a bell? Because if it doesn't, I want to make sure we hit it because it's very important for today that we understand the actual fundamentals and foundation of this, okay? All right, where's cosine of x equal to negative square root of 3 over 2? Where would that be on your unit circle? 7 pi over 6 is 1. Another one is,
7 pi over 4.
what was that?
7 pi over 4.
7 pi over, say that again.
7 pi over 4.
I think,
No.
I think because we're doing negative square root of 3 over 2, right? So I have 7 pi over 6 is 1. What's the second one?
There is.
I think there is. 5 pi over 6, isn't it? Isn't it? And I saw you, Kayla. That's exactly right. 5 pi over 6 would be the second one, okay? All right, Kayla, could you help me out with this one? This might be a tougher one here. The cotangent of x equals negative square root of 3 over 3. Do you want to just help me with how you started with it?
Well, I knew that it had to be negative, so it was either in the second quadrant or the fourth quadrant.
Great,
And
yeah.
I saw that there was a 3 in it, so I knew it was either 5 pi over 3 or 2 pi over 3, and then or.
I love that. Yeah. So what Kayla did is a little bit different than other people, but it's still correct. She said, okay, tangent's negative in the second and the fourth, and I know that it's square root of 3 over 3, so I'm going to focus on either the values that are over 6 or over 3. So I've got to figure that out. Well, remember, cotangent is it y over x or x over y? X over y. Good, Thomas. And so when we look at x over y, we focus on that, and when we do the square root of 3, or negative 1/2 over square root of 3 over 2, 2 pi over 3 would produce negative square root of 3 over 3. Okay? Am I making sense on that? Is there anyone that's like struggling? So therefore, if the 2 pi over 3 is correct, then 5 pi over 3 would be correct too. Okay? Rocking. Rocking, rocking. If you haven't gotten food yet, go ahead. Go ahead over. Okay? Alrighty. Alright, we're going to get into the meat of this today. Now, I will tell you that this is not as hard if you get what we just did. This becomes extremely hard if you did not get what I just went through, okay? All right, let me say that again. What we just did, those 4, are essential for where we're headed. If you get that, you're good. If you don't, it's going to be a little tricky, okay? All right, someone help me. What's an inverse? What's flipped, Graham? You're right. I love it.
2 would be 1/2.
X and Y.
Yeah, so this is the first one, right? And by the way, this is just an example of what an inverse is, okay? If I looked at 2x here, the inverse of it, when I found it, would not be multiplied by 2, but divided. Good. And notice I didn't really subtract 3 up here. I would actually do what? I would really just add it, okay? And then divide by 2. So what did we actually do here? This is like from algebra, right? Does anyone know what I would do to solve for the inverse of this? This is like SAT stuff. Okay, so if this is y, right? What am I going to be solving for, Emma? Yes, so we're going to say x equals 2y plus 3. Good, what would we do next? Subtract 3 by solving for x, and y'all are right. To get x minus 3 equals 2x, or 2y, my fault. and solve for the new y. We divide by 2, and that's how we get, and the 2 would go to both, right? So this would be like x over 2 minus 3 over 2 equals y, and a lot of times we put a little -1 on the top, which refers to the inverse.
Is this
Cool.
a ticket for green?
Say that again?
Is that ticket for green?
Yeah, it was for Graham there, but this one's for you from that last one. You and him. Okay? All right, questions on what an inverse is. All right. Just threw it right in the middle. Sorry, Emma. So someone help me. How are these reflected? So here's the graph of the first one here. Here's the graph of the second. Someone raise your hand and help me. What do we see about the reflection of this?
They cross.
The X and Y.
Say that again.
The X and Y.
Yeah, the x and y are flipped. What do we say that's symmetric over? 4 tickets if you know. That's pretty good.
Perpendicular?
It's close. It's very close. Kind of, it's not, because it doesn't create a 90 degree, but it is in a lot of ways very close to that. Very close. I loved your dad yesterday, by the way.
Thank you.
It was awesome. It was awesome. I was telling my wife about it. It was awesome. Really cool. Does anyone know? It's symmetric over the origin. Y'all see it? It's over this y equals x line. Got me? It's reflected over top of it. That's how an inverse is created. Okay? So watch this. I want to go backwards just for a second. I'm going to give you the big picture, and then we're going to go to the details. Okay? All right. Here's the big picture. If cosine of x equals negative square root of 3 over 2, how would I solve for x in this example? How would I get x by itself? And you can't say divide by cosine. Can't do that. Okay? You can't do that. Emma, do you remember? Correct. Don't we do this? We take cosine inverse of both sides. Okay? Do you see that? We take the cosine inverse of both sides. Well, here's what we're doing today. You ready? Here's where we're headed. I'm glad that came to you there. Really, what we're doing here is we're then saying x is equal to cosine inverse of negative square roots of 3 over 2. You see that? Because we're solving for what? We're solving for x, which is an angle, right? You remember this? It's an angle. So we're solving for the angle. But here's the deal. What happens is this looks very similar to this, and in a lot of ways it is. But there are some things that an inverse has that a regular cosine does not, okay? An inverse cosine has what we call a restricted area, okay? Now, this next part that I'm going to hit on, you just need to be familiar with it. You don't need to memorize it, okay? So this next part, why is it restricted? Well, I just want you to see real quick. This is brief, just the y behind it. If I have a regular cosine, what's up, Grace? You looking for your water bottle?
Yeah.
It's right over there. Right on.
Okay. Cool. Thank you.
Right on. Grace, everybody. Right on. I thought Grace was her. Can I tell this?
What?
I thought her name was Grace Ann
Yeah, everyone.
at first. I don't know why, but we're corrected, right?
Mhm.
Grace, have a great day.
You too.
So when I look at the cosine graph, this is a regular cosine graph, right? Okay. I'm not going to go really in depth about this, but I just need you to see this. This is a regular cosine graph. This is in what we call arc cosine. This is a good thing to get down if you've got it. Or cosine inverse. Both of these mean the same thing. Okay? Arc cosine and cosine inverse are the same thing. All right? Now, question. Here's a question for you. What is the domain? Or domain is like, what's the furthest left and right that a cosine graph goes? Yeah, it kind of goes from negative infinity to infinity, doesn't it? And as I look at this, you realize that the range of this traditionally goes up and down 1, right? It goes up and down 1. Well, question with this. How is this restricted on my range? How far up and down does this go? Well, up it stops, doesn't it? For this one, where does it stop at? Pi, and it doesn't have a label down here, but this would be 0. Okay? I'm going to get to this, where it's used in a second. So what am I saying? A cosine inverse is restricted from 0 to pi. Get that down. Okay? So when I say arc cosine or cosine inverse, both mean the same. They're just gangsta signs there. Okay? Different, same names. These right here have a restriction from 0 to pi. 0 to pi. Okay? Now question. When I taught this before, Did this have a restriction down here? Not the yellow part, but this. No, it didn't, right? You found 2 answers normally, and then you solved for it. It's much different when I solve for the cosine inverse of this. It's restricted. And so what we're going to do is we're going to take this restriction and take that into account, all right? Look real quick at sine. Sine doesn't have it here, but tangent's very similar. This is the regular tangent. The range is from negative infinity to positive infinity, right? What do we notice about the restriction for tangent?
The range is restricted.
Yeah, which is what?
The y.
Pi over 2 e? Negative pi over 2. So when cosine has a restriction from 0 to pi, tangent and sine, put this down, tangent inverse and sine inverse have a restriction from negative pi over 2 to pi over 2. Okay? All right, so you say, Coach, what does this mean? All right, let me make sense of this. Maybe this will help. All right, so when we do regular sine, cosine, tangent, am I restricted? We're not, but you could just keep going, right? Coterminal stuff takes into account, like it just keeps going. But when we talk about inverse, okay? When we talk about inverse, we're talking about sine inverse, cosine inverse, and tan inverse, or what else is another name for these? Arc, whatever it is, right? Arc, fill in the blank, sine, cosine, tangent, same thing. Where can cosine inverse exist? This is 0.
First and
0 to pi. So it can be in either the first or second quadrant. Nice. Okay. 0 to pi. So this encompasses cosine inverse. Okay, are we good so far? I'm going to go to problems here in a second. I think it'll make sense. When I look at tangent and sine, where can those exist? 3 and 4. Oh, 4 is right. That's good.
4
And?
3. 2.
So this is pi over 2 to negative pi over 2, right? If someone said 2 and 3, I hear what you were saying. Actually, it exists from here to here. So in the first or fourth. Okay? First or fourth. So it goes from pi over 2 to negative pi over 2. All right? All right, did I confuse the mess out of y'all
Pretty
yet?
much just flip.
That'd be great. Yeah, please. Please do.
Good shit.
Yes, sir.
Pretty much both like cosine's negative and
It's like flip, right? So cosine would be positive.
Yeah, this is where cosine's positive.
Yeah.
This is where cosine is negative, right? In our range. Over here in sine and tangent, this is where this is positive. This is where it will be negative. Okay? So are there any inverses that exist in quadrant 3? There's actually not in our range. Okay? Cosine exists in 1 and 2. Sine and tangent inverse exist in 1 and 4. Okay? Now, you say, Coach, what in the world? Again, I told you, if you knew the bottom 4 at the beginning, it's going to be a lot easier. A lot easier. Okay? So what we'll do, let's go into problems. Let's see what this actually means, and we'll go forward, right? Question, before I do that, how many answers does sine of x equals negative 1/2 have?
2.
There's 2. Graham, do you know what ones they are? I know I'm putting you on the spot.
No.
It's fair. Does anyone know the answers to that?
Yeah.
What are the values where sine of x equals negative 1/2?
Oh, 11 pi over 6,
Yes? And?
7 pi over 6.
Okay, good. Okay, so I want to just show you this real quick. Is that correct if I gave you that answer? Yes. However, if I gave you, this is the different part here, okay? If I say sine inverse of negative 1/2, technically, all I did was solve for x, right? But if I give you this, we're restricted. Y'all follow me? So, what we have to do is say, what one of these values falls in my range? Well, remember, 7 pi over 6 is over here, right? 11 pi over 6 is over here. Which one falls outside of my range?
Outside of
7 pi.
7 pi over 6, y'all see that? So, we actually get rid of this. We keep 11 pi over 6, okay? However, 11 pi over 6, do you see it's still outside of my range a little bit? You say, Coach, why? Well, when I was a kid, I was always mischievous. I was never like in the world, but we always did crazy stuff. And one of the things we used to do, I can't believe I'm telling you this, is we would go through people's yards and we would tie stuffed animals with fishing line. This is really dangerous. Don't do this, okay? And when I was like in middle school, I would noose like a stuffed like Barney. And what I would do is I would go into different people's yards, throw it across the street, and then when it was dark at night, like reel it in when cars were coming down. And so what would happen is we always did it at the low point, like when it was like cars would fly. We were just trying to teach them a lesson and not speed. And so we would like pull it in, and there's this like Barney coming in, and they would like screech. They're very dangerous. Don't ever do that. The reason why I tell you that is to teach you a lesson, and I don't know why I just told you that, but also to tell you that if this is the area, these two, where sine inverse exists, I cannot trespass over here to get back to my property. I'll say that again. I don't know if that helps or not. If it doesn't, just ignore me. This is where sine and tan inverse exists. I cannot go outside to get inside. Am I making sense? So what I've got to do is find a coterminal angle that goes backwards that exists to where I don't go outside of my property line. You follow me? You tracking?
Can it be negative
Partially, right? It's
negative pi over 6?
yeah, there you are. Negative pi over 6, Kennedy in red. You're exactly right. I'll get you one right here in a second. Does that make sense? So we say that it would be negative pi over 6. Okay? Question. If I hear you say that Coach Jay did it when he was a kid and you get caught, I promise you I'll deny it. Okay?
What's the worst thing that happened?
Well, my brother, I dared my brother to throw a water bottle out of the car, and that wasn't a good idea. That was another instance. But he did. He was a full water bottle, nailed the car. Car turned around, came in to our driveway, told my parents about it, and he got spanked, and I got spanked too, because I dared him. He's like, my brother dared me. I was like, thanks, dude. Appreciate you. Appreciate you. But does that make sense? Does that make sense here? Okay. So let's do a couple of them, make sure that we get this, okay? See if we got this part here. Hey, you know this, X and Y are flip-flopped, right? This slide, I'm just going to say quickly. When we flip-flop X and Y, what happens is the inverse goes from this graph to this. It still is reflective over the origin. Y'all remember that? So if I took both of these, they would be reflected over the origin like I did at the very beginning. Don't have to memorize that. Just know that's how we get to the answers and how we get to our restrictions here. Okay. All right, so here's all the guys. Here's some more pictures of our guys here. Down here, there's Ben. I don't know what he's doing.
Jeff?
And there's Jaja
that Jeff?
and Roy here. Yeah, this is Jeff over here. We can see. Yeah, here we go.
Wait, where's Roy?
There's Jeff. There's Roy right there. That doesn't surprise me, that picture. That doesn't surprise me there. All right, so let's do this one real quick with your group. I just want you to try it out, okay? Our cosine is the same as cosine inverse, and sine inverse is the same as our sine, okay? I want you to find what the angles are, okay? Is it hard to see there? See if this... Does that help? Whoa, that's bright. Our cosine is 1/2. Try to find where it is in our range. And sine inverse is square root of 2 over 2. Try to find that in our range, right? Real quick, with someone next to you, go ahead. Let's do it. See if we get this. Okay. What do you think? This makes sense?
It's only one in
Yeah, I can't. It looks better on mine on the screen. It looks awful. Let me do this. Sorry, y'all. I'm coming back to this in just a second, okay? Oh, hold up. Did that help? No, not really.
Wait, Coach Jay.
Does that help?
Yes.
Much better.
Coach Jay.
Yeah.
Why is that like our
Coach
range?
Jay, is this right?
That's just how it is.
Well, remember I told you, like, when we have something that is an inverse of something else, what happened was is on the previous one, the graph was transformed. Where it normally is not restricted, this time it is restricted. And it's restricted at certain places when we say, what is the sine inverse of this? So we can't get values that are outside of the first and the fourth quadrant. It only can be between, like the graph can only be between the first and the fourth. I'm trying to think of. It'll be negative. Yeah, so you're exactly right. So if I was to draw this, right? So the graph for a sine inverse, you don't need to know this. You don't need to graph it. You just need to be familiar with what the range is. The range of this, the lowest point would be negative pi over 2. And the highest pi over 2. So what does that mean? That means that anything that is above pi over 2 or below, sine inverse does not exist in that. So because of that, for inverse, right? Sine inverse, it doesn't exist. So because of that, that's why it's got to fall on the. And when we draw it on a unit circle, it's kind of what we've been focused on, that exists between the first and the fourth quadrant. Got it?
Wait. But like 11 pi.
It's inside, isn't it? It's inside, but 11 pi over 6 is still above pi over 2. It's in the right location, but we need to say it a little bit differently. If you went to 11 pi over 6, 11 pi over 6 would go here, right? If I drew it, 6, I'm trespassing, right? I'm trespassing. Still, even though I fall in my property, I'm still trespassing. So we got to go backwards. So we just say what's easy is when I say 11 pi over 6, instead of saying that, you say negative pi over 6.
So
Does that make sense?
yeah.
Cool. All right. Does someone for tickets want to just explain it verbally for me? And then try it out. Josh, go ahead. Start with arc cosine of 1/2.
So arc cosine is the same thing as inverse cosine. So you go to where's 1/2 cosine?
Yeah.
So cosine's your x, so it's 1/2.
All right, do this. Hold on, Josh, just a second. Hey, help me out just for a second. I know we're moving, getting stuff. Just so that I know there's a couple people that are still like a little question on this. I want to make sure we hit. Go right ahead.
So our cosine's inverse cosine. You go to where cosine's 1/2. So that's pi over 3 and 5 pi over 3.
Good. So pi over 3 and 5 pi over 3 are the two locations where they exist. Good. Keep going, Josh.
Now cosine is only in the third quadrant 1 and 2. So it cancels out the fact that it can be 5 pi over 3.
Good. So remember, this is the range where it's in blue where cosine exists. That's the range, right? So that means, remember, this is outside of its property, all right? Does not exist in terms of cosine inverse, and that is why in this example, pi over 3, like Josh said, would be our correct answer, okay? Am I making sense on that?
Yes.
All right, Diego, do you want to just help me? Let's just try for the second one.
Alright, so sine. So then if you look for -2 over 2, so it's going to be like in the first quadrant
Okay,
and in the second quadrant.
first and
No,
second. No, you
fourth.
said that right.
Oh,
Yeah.
it is?
So where is sine square root of 2 over 2 location-wise?
Like pi over 4
Yep, and?
and
4,
3 pi over 4.
3 pi over 4, nicely done.
And it's gonna be pi over 4.
Why is that?
Because it's in the first quadrant, like the first two or that one's sine, the first one's sine.
Good, so in my range in an inverse, it exists within the first and fourth quadrant, or between pi over 2 and negative pi over 2. Anything outside of this, I was talking to Ty about this, anything outside of that, as far as the sine inverse and tangent inverse, is outside of my property. Can't go in there. So that's why, even though if I said sine of x equals this, I'd put both answers. But when you put sine inverse, we restrict the domain, and at this point, we only can have it within the first and fourth. Make sense?
Yes, sir.
All right, question, Mary Grace, you ready for this? I'm putting you on the spot a little bit. I think you got it. Negative square root of 2 over 2, I didn't ask for it here. But if I did, where would that exist? Negative square root of 2 over 2. Get this down just so you can kind of get a rep in right here for a negative value. The fourth quadrant, I like it. And what would that value be? Okay, yeah, and you did that perfectly. If I did this, it's actually at 7 pi over 4 on my unit circle. Why can I not do that? Mary Grace already kind of fixed it and put it out there already. Why is it not 7 pi over 4 here? Can someone explain, Kennedy?
Because it's not in your property.
It's not on my property. Good. And Ty, then, what would I do with 7 pi over 4 to get it inside of my property?
You would have to do negative pi over 4.
Bingo. Bingo. So anytime I'm in the fourth quadrant, just remember that for inverses, we just use the negative value of that. Because if I went outside of my property, which is here, to get in, that's still not good. We got to go backwards. Okay? All right? If you're good, say uh-huh. Does this connect? Does that make sense? All right. I hope so. This is sometimes a tough topic for us. Okay? Good, good.
Wait.
Go ahead. Yes, I am podcast. It's good. Yeah, Ty?
If our range is pi over 2 and negative pi over 2,
Yeah.
how is cosine in the second quadrant?
That's a good question. When we look at, that's for sine and tangent. It's a great question. When we look at cosine, remember the picture I was talking to you about? Me and you over here? Look at the cosine inverse. It's a little different when they do their value, right? Because when you do this one, you start at the top for a cosine, come back down. So the actual value on that would start at 0 and go to pi
Okay.
for the inverse. That one's the only one that's different.
Gotcha.
Okay? Cool. All right, good, good, good. Okay. Do this. Take out your calculadora real quick. Okay, we're going to do something really fast. I want to get to this, and we're good. I've got 2 slides left. Got me? 2 slides left, and we're good. Okay? All right, so really fast. When we look at this here, I want you to put your mode into radians. Okay? Put your mode into radians. See, where's my calculator? There we go.
We have to do both modes. Switch it over.
Sometimes-
Is it dangerous to have it in the wrong mode accidentally?
Sometimes it will go into both. The ones, here's the kind of overall, and we'll go through specifics as we go through the review. If I say if I'm solving for like the height of a building, it's a word problem, degrees. If I am solving for like a value, like this is more of just, hey, what is this? Tan inverse of 5.9. Traditionally, we've done radians, right? If I plug in radians, I'm usually going to get out radians. If it doesn't say, and it's not a word problem, just default radians there, okay? I'll be a lot more specific as we go through, as you see all the problems as a whole on the review, okay? Just remind me of that, Josh, because that's a really good question. All right, so question on this. If I do tan inverse of 5.9, how do I do that on my calculator? Well, we got our mode, right? Mode is in radians, and that's what mine's in. How do I go to tan inverse?
Second tan.
Yeah, literally second tan, okay? And then afterwards, you're going to put in 5.9 in for that. And when I get this out, will I get out a value? What does that mean? I'll tell you what, I'll give 3 tickets if you could tell me what I just did in terms of tan inverse of 5.9.
Radians.
Say again, Grant?
And radians
Radians of what? You're right.
of 5.9. Or of tan.
Yeah, tan, right? Tan inverse of 5.9 would end up being what? The radian angle, right? Radian angle. So question, 1.40 is in what quadrant? First, right? Does that make sense? Red, do you know why?
Because, I don't know, 3.15 is pi.
Nice.
So, like, going back, that's like 1.47.
Correct.
And it's less than 1.47. So,
Good. So is that my range?
yes.
Yes. Here's the thing. If you just connect that dots, that's pretty good. I think you got it. Nicely done. All right, questions on that? Calculator problems? We're just plugging in. Make sure it's in radians, and if you do that, you'll be Gucci. Okay? All right. Here's the.
Does the negative change anything?
Coach Johnson.
Let's try it out.
That one,
Let's try it out.
for that one, the answer is just what we just did.
This one right here,
Oh,
No,
or the
one circle.
answer's this 1.40. Josh had a good question. If we did 0.7 or negative, is it negative 0.7? Negative 0.7. Let's see what happens. Yeah, you'll notice something. It's an error, right? Did you all get that same thing?
Yes.
So did you get negative 0.7? Why did we get an error?
I got an answer.
You got an answer?
He's just got
Did I put it in wrong?
Maybe you're using minus instead of
Oh
negative.
yeah, I got it.
Yeah, I think you're right. Bad Coach Jay. You're right. There we are. 2.35. Is that okay? Is that in my range?
Uh,
Yeah, because this is 0. This is 3.14.
Yes.
and 2.3 falls somewhere in between. You figure that out? And here's the thing, you won't have to answer that question, just be able to find it using your calculator, okay? Sound good? All right, here's the deal. We're going to go into one more section. Tell you what, I want to do, I think I've got some on your homework. Can we do a couple on for your homework real quick for this one? Because I feel like I've talked a lot, and then we're going to get into character development review game. Okay? That's kind of where we're headed. All right, here we go. Let's go to, is this one on your homework right here?
Which one? Which one?
No, this is different, isn't it? This is different. Go to number 2. Okay? All right, so real quick with me. A, B, C, D, E, F, G, you should be good on. Okay? Doing those. I'm guessing that's like checkpoint off. We've done that. Okay? What we're going to do is numbers 2, 3, 5. Did I skip 4? Good job, coach. 2, 3, 5. Math teacher. 6. We'll hit on one of those and just make sure we got those. Okay? All right, so we're just going to kind of make sure we understand this. So really quick, we're going to look at 5 and x plus 2 over here. And then I think that's blank. That's blank. Okay. Theta is the same. I think that's right off number 2. Okay. All right. It says write the following 2 triangles. There's only one. I deleted the second one on that one. In terms of a trig function, and write theta as a function of x. It's kind of weird. Really what we're looking for is to solve the angle. If I were to solve the angle, we've kind of done this before, how would I solve it in the context of this problem? If you solved it, you could use the Pythagorean theorem, absolutely. But I could actually do it already without even solving for that, couldn't I? Elijah, do you know what we would do on that? All right, so question, what is the, in relation to theta, right? X plus 2, is that opposite, adjacent, or hypotenuse? Opposite, Rocky. Good, Elijah. What's 5? Hypotenuse, good. So what type of trig ratio would I attack here? If I've got opposite and hypotenuse, I can attack it using sine. Isn't that right? You remember this? So what we would say is sine of theta equals, what would it be? X plus 2 over 5. Okay? You'll like this problem. This one's not too bad. Piece of cake, I think. But if it asks, the weird thing is the wording. It says write it in terms of theta as a function of x. What that means is x is in the answer. We're solving for theta. Okay? That's what English, kind of what it's saying there. So how do I get theta by itself? Yep, we're taking the sine.
Divide.
Can you divide? Sine, how do I break that up? Sine inverse, there you are. So sine inverse of both sides, this right here is my answer. So how would I write that? Well, this would cancel. Theta equals sine inverse of x plus 2 over 5. I think we've done this before. The only difference is we're using variables when we don't know what x is. Okay? All right, questions on that? Okay. All right, here we go. You ready for the next one? These next ones are kind of fun. All right? That would literally be it. Sine inverse of x plus 2 over 5. It's a, what do? We wrote it as a function of x, right? Theta as a function of x, which just means x is in our answer. We're solving for theta. Okay? Am I making sense here? This is heavy. This is not the most exciting stuff in the world. Okay? I know that. We're almost done. We've got a couple more left. Okay? All right, this next one you'll like. Question, cosine inverse of cosine. Well, we kind of already did that, didn't we? We went up here and we actually did sine inverse of sine, and what happened to it? We canceled them out. Y'all get that? We just simply canceled them out. Here's the kicker, okay? When we do that, we can do this. What's our answer? 3 pi over 4. Here's the only thing you need to check, because they're going to trick you on this. Is, Ty, here's a good question for you. Is 3 pi over 4 in my range for cosine? That's the only thing I need to check. It is. Good. Because it's between what?
0 and pi.
Good. Did you hear that? So you just cancel it. You just got to double check. Is that between 0 and pi? If so, then you're good. You check, you're good. Okay? So that would be my answer. All right, here we go. This is where it gets a little tricky. Okay? This is where it gets tricky. Let's see if we can do this together. I'm not going to tell you. I want to see if we can figure it out. Okay? Paige, what would we do at the beginning for this first one? Cancel out the sign. Okay? 3 pi over 4 is over yonder. Okay? It's 3 pi over 4. All right, Paige, help me out with that. What do we know about this?
Sine isn't like, it's not in the range that it should be.
Yeah, it's outside of my range. It should be here to here, right? It's outside of my property. You're right. Someone else help me. What would I do with 3 pi over 4 to get me inside the range? Elijah, was that you? You don't know? Okay. Got you, right?
Like a co-terminal to get it back in. Or
What?
to subtract.
Okay, so you say add 2 pi here?
Yeah, find the angle.
Find the angle 2?
I don't know. Something like that.
Okay. I like the thought here. I like the thought.
Subtract
I know that.
Subtract what?
subtract 2.
Subtract 2 pi. How many of you think subtract 2 pi? I want to just show you because I'm wondering. If I took 3 pi over 4 and subtracted 2 pi, I'd get a 4 on the bottom. What I do to the bottom, I do to the top. This would produce what? Negative 5 pi over 4. Check me on that, but I think that's right. What that means is I start here and I go backwards to there. That's negative. Isn't that what that means, right? Is that correct? No. Because that's outside of my what? Range. Someone else have another idea. These are good thoughts. Why'd you say it's negative pi over 4?
Something about the distance between
Subtract
the range.
All right, question. I like this. Over here at 3 pi over 4, when I do sine of 3 pi over 4, what is sine of 3 pi over 4? Root 2 over 2. Would you all agree with that? Sine of 3 pi over 4 is square root of 2 over 2. That's an awful color. Sorry about that. Let me do this. So we get square root of 2 over 2. It's here. Then I do the sine inverse of that. Y'all follow what I just did? I just worked. No? No? Okay, fair. Let me see if I can teach it different. If I did 3 pi over 4 and I looked at sine, Kennedy, would it make sense that this would be positive square root of 2 over 2 for sine?
Yes.
Does that make sense? All right, so question. Maybe this is better. I like this better. If I looked at my range, which would be here and here, can you pick out a place where sine would also be square root of 2 over 2?
Pi over 4.
Bingo. So what's my answer inside my range?
Oh,
Pi over 4. Maybe that helps you better. I think I like that better.
when you did, what were you gonna do with the sine?
Over here, what I did was work inside out. So sine of 3 pi over 4 is square root of 2 over 2. Sine inverse of square root of 2 over 2 would be pi over 4. So it's just another way of saying it. I like the second way better, but either way would work. Mary Grace? You can do that. I'm trying to think. You can't do that for tangent, though. Because tangent would be negative in quadrant 2, and it would be negative in quadrant 4. Does that make sense? So you could do that for sine, if that makes sense in your head there. But you couldn't do it for tangent, if that makes sense. Okay? All right, how do you feel on this? Does it make sense for both of these, why it would be different?
Is the answer negative pi over 4 or pi over 4?
Just pi over 4. The reason why is negative pi over 4 would be a value of square root of 2 over 2, but it would be negative square root of 2 over 2 for sine, right? So that's why it would have to be up here. Yeah?
Do we have to memorize the restrictions?
The restrictions, I would say yes, because this is more application, like knowing that. Just remember sine, tangent, and cosine. Like cosines 1 and 2, sine and tangent are 1 and 4. We'll do more practice as we go. I think that would be good. Questions off that? All right, I know it's been heavy. We're almost done. One more slide. You good? I think these are straight off of your, I think these are straight off the backside or the front too. Some of them are, right? Some of them are. Some of them are off the back too. So this is straight off your homework, I know, here and here, okay? What would I do on these two? Literally, you cancel. Now, this is a little weird. If you see something that looks like this, that's just a value, right? Because if I took cosine inverse of this, I'd get an angle, and cosine of that would be a value. If you just see a value that doesn't have a radians or degrees, this is your answer every time. Okay? Cool? So tell me what this one would be, Graham. 0.3. 0.3. That's it.
I like those.
Boom.
I like those too.
Okay? Here's what you got to be careful on. If I flip-flopped arc sine and sine, and I went sine inverse of sine of let's say square root of 3 over 2. I'm sorry, not square root of 3 over 2. I'm sorry. 2 pi over 3. You see the difference? I have to cancel and make sure that this is in my range. Y'all Gucci on that? You see the difference? Okay, good. All right, one more type of problem and then I'm done, okay? We'll do a homework one. You good with that? All right, let's do this one. Let's start with this one, okay? Okay, just a little different. Pretty much the same thing we did earlier. We'll wrap up with this one, okay? Cosine of arc sine of 2x. So real quick, we're going to break this down. This one you can't cancel. Why? It has a variable, that's true. And they're not the same one. Good, Thomas. So they're not the same. So now, I've got to look at this and see, what do I do to set this up with a variable? Well, this one, again, works a little different. We're going to start with arc sine of 2x, okay? All right? So we're saying, what is the angle when sine is 2x? All right? What is the angle when sine is 2x? Or I could say, sine inverse of 2x over, what's it over? 1, right? Okay? What is the ratio of sine again? Opposite over hypotenuse, okay? So this is how I draw it. I draw a triangle. These ones you got to draw a triangle on. I always put theta in the bottom, that way I know where I'm focused on, okay? All right, so when I attack this one, Josh kind of said this earlier when he said the Pythagorean theorem. This is where we're going to bring it in. Where does 2x go? Opposite side, good. Hypotenuse is? 1. What's the side I don't know? The adjacent, okay? The reason why I have to solve for the adjacent here is because what do I have to do once I've set up the triangle? Okay, yes, and you said what, Graham? Solve for cosine, which is, Kennedy, you said it, adjacent over hypotenuse. You follow me on this? So in order to solve for cosine, I've got to find the adjacent to put over 1, which is my hypotenuse. All right? So it's all through a triangle. I start inside and work my way out. So we'll label this as M. I don't know, whatever you want to. Okay? I just thought about Michigan there. All right?
Or money.
Money, yes. Or money, yes. Put the money sign. Good. All right, so how do you solve for M? Pythagorean theorem, good. So we would do what? What would be the setup?
2x plus b is 1. I mean 2x squared plus b squared.
Good. That's exactly good. That's exactly right. So we would do 2x squared. We want to make sure everything in 2x would be squared, right? Everything. Plus m squared equals what? 1 squared. This becomes just more algebra than anything. When I do the squared part, what would this produce? 4x squared. Both parts are squared, right? Both parts are squared. So 4x squared plus m equals 1. How do I solve for m? Good. And when I do that, what is m equal to? And I actually messed up. It should be m squared, right? So m squared is 1 minus 4x squared. Can I add those together?
Yes.
The 1 minus 4x squared? I can't because they're not like terms. That's okay. That's okay. So now I get m by itself by doing what? Square root both sides. So what is m equal to?
Square root of 1 minus 4x.
Nice. Yeah, and that would be.
Wait, the 1 on the second level still be 1 squared?
Where was this again? Right here.
Like above that.
Right here. It would still be 1 squared. We could actually do 1 squared is 1 times 1, which is just.
Can't the square cancel out? Listen.
That's a great question, Josh. The square root cannot go into here. So you have to leave it as square root of 1 minus 4x squared. Because of the minus in the middle. Now, if they were multiplied, yes. But because it's subtracted, you cannot allow the square root to go to both. We just leave it like that. Okay? So what is the cosine of this? What's the adjacent?
That.
This, right? Square root of 1 minus 4. I like how you said that. Square root of 1 minus 4x squared over 1. And you could just leave that because the hypotenuse would be 1 here. Okay? Are y'all good?
That's our answer.
Be our answer. Okay?
Why is it over 1?
Good question. What the cosine is adjacent over what? Hypotenuse. Hypotenuse was 1. How did I know the hypotenuse was 1? Because over here when I did the arc sine and that set up my triangle, That also was 1.
So it's all for the cosine of that triangle.
You're solving for the cosine of the triangle created from the arcsine of 2x. Okay? All right, how does that feel? This is really just like a hodgepodge of different things. So great job today. Y'all rocked it. Okay, here's the deal. That was heavy. It's a long time. Let's take a breather. If you want another rep and you just feel like, Coach, could you just talk to me about something for the next 2 or 3 minutes? If you want to, you can take